A buffer tank acts as a thermal energy battery for heating hot water or chilled water systems that lack enough water volume during load conditions to avoid short cycling. They can be used with geothermal heat pumps, chilled water systems, low mass boilers, and low mass radiation systems. We'll show you how they work and how to calculate the size of two buffer tanks, one for a chilled water system and the other heating hot water. A buffer tank serves several important functions. Preventing short cycling. Buffer tanks prevent short cycling of boilers, heat sources, and chilled water systems. Short cycling occurs when the heating or cooling system turns on and off rapidly due to small fluctuations in demand. This can be inefficient and cause wear and tear on the heating and cooling equipment and is one of the top causes of failure in a heating system. The buffer tank provides a reservoir of heated water, allowing the system to operate more steadily. A buffer tank can help prevent a compressor from short cycling during load in a geothermal or chilled water system. Sizing buffer tanks. Here are two different formulas, one for a geothermal heat pump system and another for a chilled water system. Chilled water buffer tank sizing. The following formula is offered by one manufacturer of buffer tanks, and any calculations you make should be confirmed by a mechanical engineer or the manufacturer. Volume of buffer tank equals C times VR minus VA, where C equals chiller capacity in tons, VA equals actual chilled water volume in gallons, VR equals recommended system volume per ton as recommended by chiller manufacturer. We'll need to make up some values for this example. Let's say we have a small chiller of 100 tons and the manufacturer requires 6 gallons per ton minimum volume. If we use this information, we can derive a value at which anything below that value would require a buffer tank. 100 tons times 6 gallons per ton equals 600 gallons minimum system volume. If the actual system volume is less than 600 gallons, then a buffer tank becomes required. Let's say our system volume is 480 gallons. Chilled water buffer tank calculation. Chiller buffer tank volume equals 100 tons times 6 gallons per ton minus 480 gallons equals a 120 gallon buffer tank. From the calculation, we can see that for every gallon the existing system total is under 600 gallons, another gallon is added to the tank capacity to provide the minimum required of 600 gallons of system volume. Water source heat pump buffer tank sizing. The following formula is offered by one manufacturer of buffer tanks, and any calculations you make should be confirmed by a mechanical engineer or the manufacturer. The calculation is meant to allow for the boiler or source of heat to run for a minimum amount of time before cycling off. V equals M times QH minus QM divided by T times 500, where V equals buffer tank volume in gallons, M equals desired heat source minimum run time or on cycle time, minutes, QH equals heat source output minimum, BTUs per hour. QM equals heat output for minimum system load, BTUs per hour. T equals tank temperature rise, delta between supply and return, degrees Fahrenheit. 500 equals 8.33 pounds per gallon, weight of water, times 60 minutes per hour. For our example, let's assume that we have a heat pump that outputs a minimum of 60,000 BTUs per hour and that the manufacturer recommends a minimum cycle time of 10 minutes and that the smallest zone is 9,000 BTUs per hour and the radiant heating zone's allowable temperature differential is from 90 to 100 degrees Fahrenheit. If zones 1 through 3 were off, and only zone 4 was running at 9,000 BTUs per hour, our calculation would look like this. Buffer tank calculation. V equals 10 minutes times 60,000 minus 9,000 divided by 100 minus 90 times 500 equals 102 gallons. Here's what happens during load conditions. The boiler or compressor turns on and quickly satisfies demand, shutting off just as quickly because of load conditions. This short cycling of on and off continues under low load conditions, creating additional wear on the boiler or compressor. So by adding additional load and water volume with a buffer tank, this short cycling period is reduced or eliminated during low load periods. A buffer tank is basically an insulated storage tank that adds additional mass to absorb or reject heat during low load conditions to prevent short cycling of the equipment, to prevent accelerated equipment wear. If you like that video, please give it a thumbs up and subscribe to our channel. Thank you.